These are problems 39 through 44 on the AB Fall Multiple Choice Review Packet. 39. The total number of relative max and min points on the function whose derivative given by f prime of x equals x minus 3 squared, x plus 1 to the fourth is. So if we want to find the total max and min points, here are the steps. We're going to find f prime, create a sign line, test the intervals, and count the number of sign changes or count the number of relative extremas. So first, we're already given the f prime function, so we can set f prime equal to 0. The critical points are at 0, 3, and -1. We put those values onto our sign line, and then we test each interval. So if I choose -2 here, and I should look to see whether each of these parentheses will give me positive or negative. I don't have to test the last parentheses since this is raised to the fourth power. So whatever I plug in will always give me positive. I just need to worry about these two, the signs of these two terms multiplied together. So if I plug in -2 for the first interval, -2, that's negative. -2 minus 3, that's -2 squared. Actually, this is also squared. I didn't see that. We have to the fourth, that's a positive. That's always positive. X minus 3 squared, that's also always positive, assuming it's not 3. So really, it's only x that's determining the sign of our slope. So if I plug -2 in, that's negative. If I plug -1/2, it's also negative. If I plug in 1, that's positive. If I plug in 4, that's positive. So there's only one sign change, and that is at x equals 0, so only one minimum. Number 40, on the closed interval from 0 to 2 pi, find the maximum value of the function f of x equals 4 sine of x minus cosine of x. Okay. So if we want to find the maximum value on the closed interval, that is an extreme value theorem. We have to apply extreme value theorem steps. And the extreme value theorem tells us that we can find the maximum on a closed interval if we test the endpoints and test the critical points. Okay. So first off, the endpoints, 0 and 2 pi. We're going to plug 0 and 2 pi back into the original equation. So 4 sine of 0 minus 3 cosine of 0 is 0 minus 3, which is -3. If I plug in 2 pi, I also get 0 minus 3, which is also -3. Okay. Now we need to find critical values and plug those in. Okay. So we first need to find f prime. So f prime is 4 cosine of x minus 3 negative sine of x. So cosine's derivative is negative sine. Negative sine and the -1 in front will cancel out to be positive. So f prime is 4 cosine x plus sine x. Okay. If we want to find the critical point, we can set them equal to each other. So bring the sine over to the other side. Bring the cosine, divide cosine from both sides of the equation, divide -3 on both sides of the equation. So -4 over 3 is equal to tangent of x. So if we solve for x, x is going to be inverse tangent of -4/3. So we want to plug this critical value back into the original equation and see if we can determine what the y value is. Now, where is inverse tangent? Where is tangent of x equals to -4/3? Well, tangent is going to be negative in the second and fourth quadrant. So if x is equal to inverse tangent of -4/3, we can plug this into our original equation. So I'm going to replace the x in both parts of the function with inverse tangent of -4/3. So if we plug inverse tangent in for x, or basically the sine of inverse tangent of -4/3, well, the sine of this inverse tangent of -4/3 will be equal to 4/5, right? Opposite over hypotenuse. So 4 times 4/5, that's 16/5. And then the inverse tangent, or 3 cosine of inverse tangent of -4/3. The cosine of this measure would be -3/5. So minus 3 times -3/5. So that's going to be positive 9/5. So 16/5 plus positive 9/5 will be 25/5, which is positive 5. We can do the same thing for the fourth quadrant. So plug inverse tangent of negative 4/3 in for the x. So 4 sine of inverse tangent of negative 4/3. And so the sine will be negative 4/5. So 4 times negative 4/5 is negative 16/5. And if we plug inverse tangent in for this x, the cosine of inverse tangent would be 3/5. So 3/5 plugs in for cosine of x. So minus 3 times 3/5, so we get negative 16/5 minus 9/5, so that's negative 25/5, which is negative 5. And now with the extreme value theorem, we're going to compare all the y values to see which is the largest y value. So we have -3, -3, -5, and 5. So the obvious maximum value will be positive 5. 41, the line y equals 3x plus k is tangent to the curve y equals x cubed when k is equal to. So here's the tangent line, or here's the line, right? The line has a slope of 3. So we basically want to find where y is equal to x cubed, where this function y equals x cubed has a slope of 3. We want to figure out where y equals x cubed is tangent to this line. So we want to figure out where this curve also has this particular slope. So we're going to find the derivative and set the derivative equal to the slope of 3. So y prime is equal to 3x squared, and we're going to set the derivative equal to the slope of 3. And if we solve for x, we get x equals plus or minus 1. Okay, so x equals plus or minus 1, we can just plug 1 into the x value to solve for k. So if I plug in 1 and negative 1 into the equation, I'm going to get, if I plug negative, okay, so I plug negative 1 in for x, I get negative 1 for y. So negative 1 is equal to negative 3 plus k, so k is equal to 2. And also, the other order pair is 1, 1. If I plug 1 into the equation, I also get a y value of 1. So if I plug 1, 1 into the equation, I get 1 is equal to 3 plus k, so k equals negative 2. So we have two k values, 2 and negative 2. All right, 42, we have a related rates problem. A balloon is being filled with helium at a rate of 4 cubic meters per minute. Find the rate in square feet per minute at which the surface area is increasing when the volume is 32 pi over 3 feet. So we're looking to see where the rate at which the surface area is increasing. So we're looking for S ds over dt, if S represents the surface area. We're also given that the balloon is being filled at a rate of 4 cubic feet per minute. We see the word being filled. We know that this balloon is getting larger over time. So we know this is dealing with volume, but it's a rate of change of volume. So dv over dt equals positive 4 because the balloon is increasing in size, 4 cubic feet per minute. Here's our volume equation. V equals 4/3 pi r cubed. Okay. Here's our surface area equation, which is S equals 4 pi r squared. And essentially, we're just going to find the derivative and see if we can piece together enough information to figure out what ds dt is. Okay. Now, S is 4 pi r squared, right? So S becomes ds dt. 4 pi r squared becomes 8 pi r dr dt. So essentially, if we want to find ds dt, we need r, radius, and we need dr dt. So this information is probably going to come from what we've gathered so far here. So let's go ahead and find the derivative as well for v. So v becomes dv dt. 4/3 pi is the coefficient, stays. Bring down, find the derivative for r cubed, which is 3r squared dr dt. We have dv dt, which is 4. So if I plug 4 in for dv dt, and if we can figure out what r is, then we can know what dr dt is, which we need for this equation. So let's see what else we have. We know that the volume at this moment in time is 32 pi over 3. And if we know what the volume is, value, we also know the formula is 4 pi r cubed. So if we set them equal to each other, we can figure out what the radius is. So 32 pi over 3 equals 4/3 pi r cubed. The 3 cancels out, the pi cancels out. We're left with 32 is equal to 4r cubed. Divide both sides by 4. 32 divided by 4 is 8. The cube root of 8 is 2. So radius is 2. So if I know radius is 2, I can plug 2 in for r, and that will allow me to solve for dr dt, because the other missing variable was dv dt, and we know that's 4. So 4 is equal to 4 pi radius r 2 squared dr dt. So this becomes 4 times 4 pi, which is 16 pi. And if we divide both sides by 16 pi, 4 over 16 pi is same thing as 1 over 4 pi. So 1 over 4 pi is our dr dt. If we plug in 1 over 4 pi in for dr dt, if we plug in 2 in for radius, then we can solve for ds dt, which is 8 times 2 divided by 4. 16 divided by 4 is 4. The pi's cancel out. So the surface area is changing at a rate of 4 square feet per minute. Okay, the unit of measure for area is square feet, and then we're dealing with the rate, so per minute. For questions 43 through 46, the motion of a particle on the straight line is given by x of t. So 43 says the distance is increasing 4. So distance increasing, that's talking about velocity. So we're going to find the velocity equation going through power rule. So t cubed becomes 3t squared. 6t squared becomes 12t. 12t becomes 12. 8 goes to 0. Okay, we're going to find information from the sign line. So we need to first find our critical value. So we set, where velocity specifically is 0. So if we find where velocity is 0, we can then test the intervals. So I can factor out a 3. Here's our velocity equation. We set equal to 0. Factor out a 3. Continue factoring. We get 3 times t minus 2 times t minus 2. Our critical value is 2. And then we can test on either side of 2. So if we plug 1 into the velocity, I get a positive value. If I plug 3 into the velocity, I also get positive. So this function, or this particle, is going to be increasing or moving to the right from negative infinity to 2, and then from 2 to infinity. The only time where velocity is 0 is at 2. So the distance is increasing for all t except t equals 2. Okay, the minimum value of speed is, now speed is the absolute value of velocity, right? And so even any negative velocity will end up giving us a positive value for speed. So if that's the case, then the minimum value for speed will be where velocity is 0. Okay, so minimum velocity is 0.